Good evening, my friends and fellows. My name is Edward Washroom, the tutor in Edwards Academy. This evening, I will continue the computation part of the panel data regression I introduced last month. I'm sorry for not being online for some time due to various academic challenges in other sections of my life. So this evening, I'm going to continue with the estimation procedure of the three basic panel data regression approach, such as the common constant estimation, the fixed effect estimation, and the random effect estimation. But before we proceed, I would want you to understand the intuition behind the panel data, or to refresh your memory again on the intuition behind the panel data regressions and the dynamics in it. Basically, the panel data regression is a longitudinal regression estimation that encompasses or includes cross-sectional time series data over countries, parastatals, firms, individual units, and others. So the panel data regression actually enables us to actually run regression analysis across countries and firms. So the fixed effect estimation procedure is different from the common constant and the random effect estimation procedure, because the common constant estimator believes that all countries involved in the estimations, or all firms or households involved in the estimation, have a common constant, meaning that there is homogeneities across these countries or units. Homogeneities in this constant, or in this instance, implies that all characteristics in these countries are the same. So the common constant effect is also known as the pool effect, or the pool estimation effect, because it's expected that all the variables are homogeneous across the countries. Then the fixed effect estimation requires that there are differences or heterogeneities across these countries, or these differences and heterogeneities across these countries relies on the individual intercepts or characteristics, whereas the random effects actually do not disagree with the fixed effect estimation procedure. Rather, the random effect estimation procedure believes that the differences or heterogeneities discovered across these countries is a function of the error term. So in this research, I'll be teaching you how to estimate. So this is my Eviews work file. I have just opened the work file. If I right click, I have my variable already. I'll paste my variable. I click next. Then I click finish. I'll click yes. At this level, I have my panel data work file untitled in Eviews. I'm using Eviews in these first videos. Other videos I also use Stata to actually show you how to estimate the basic panel data regression. So we have 44 observations, and we have 4 variables here. To estimate the common sample regression, which is also called the pool OLS regression, we go to quick. From quick, you go to estimation. We are modeling the log value of GDP as a function of constant, the log value of market capitalization index, the log value of financial deepening, FN. We are modeling the exchange rates and the trade openness. Without changing any other item here, without changing any other item in the option box, the model specification will remain the way it is. We leave it the way it is. If we hit the OK button, you will be exposed to a result that looks like this. This is the dependent variable. We have the method, we have panel least square estimation. So this particular result is called the common constant estimation, or the pool OLX, the panel pool OLX result. This result will now be saved because I want to make comparison. This result will now be saved. I will save this result as CC, common constant estimation, CCE. I will save it as CCE, then I will move on. So from the original estimation, which is this, I would want to actually calculate or compute the fixed effect regression. To have that done, you go to estimate. From estimate, you maneuver to the panel option. From the panel option, you change the cross section to fixed effect. The period, you change the period again to fixed period. The GLS weighted period, you leave it at that. You click OK. Then you will be exposed to this. You will be exposed to this. If you are exposed to there, this is the fixed effect regression. You can actually go back again. You go to option, you look at it again. The GLS weight, say no weight. You look at the cross-sectional weight again. You can do this, but if you don't actually want it, you could actually leave it where it were before. You have this, you interpret this, critically look at the variables, the coefficient, the standard error, the t-statistics, and the probability value. Recall that the R square is high, but though too higher than what I expected. The F statistic is 31.62131, and it is significant. So you can compute the F statistics to compare the calculated and the critical values of the X statistics of these two variables, and you move on. To compute that, use the R square of the fixed effect and the R square of the common constant sample or regression to compute the F statistics. And if the calculated F statistics is greater than the critical value at 5%, then you actually reject the null hypothesis and accept the alternative hypothesis. So I can actually save this particular result as fixed effect estimates. I will leave it at that. Then I will go back again to the original output. This is my original output. I want to get the random effect estimation. I'll go to the estimation. I move to the option. From the option, I change this to random. I change this to random. Change the cross-sectional alone to random. You hit the OK button. You will be exposed to this. Change the cross-sectional to random and fix to random. Okay. You hit this. You change this. Change the period rather. Change the period to random. You leave the cross section at none. The weighted should actually not be ticked. So if the period is changed to none, to random, the cross sectional to none, hit OK, you will be exposed to the random effects regression. The random effects regression will appear like this. The random effects regression will appear like this. We have the weighted statistics and the unweighted statistics. Remember, this is our dependent variable. The panel estimation method is period random effects, the panel EGLX. Then we look at the statisticals, the probability values, and the coefficients. The t-statistics. Recall that there's an inverse association between the t-statistics and the probability value. The coefficient is gotten by dividing the standard. The t-statistics is gotten by dividing the coefficient by the standard error. But the rule of thumb here is we want to look at the random text and the fixed effect text by making reference to the Hausman text, because the Hausman statistics enables us to know if the fixed effect or the random effect is okay. Given the fact that these are our fixed effects, we only had two of our coefficients are significant, two were insignificant. The row statistics is significant, and the period, the random period, the idiosyncratic element is actually okay. But we need to know, because our R square is 86%, somehow better. The probability value, the F statistics is high, P value is okay. but we cannot decide on what is or which of the estimation is better. To have that done, we need to perform the Hausman test. To have that done, we go to view. From view, we maneuver to fixed random effect testing. We move over to correlated random effect, the Hausman test. Then we hit OK and we'll be exposed to a result that looks like this. This is our result. This result is called correlated random effect, the Hausman estimation on title. The test period is if random effect. The test summary will have the chi-square statistics and the p-values. But the issue is that to decide which of these is better, we need to actually pay attention to the chi-square or the t-statistics of the Hausman test or the p-value. And the rule of thumb is that if the p-value of the Hausman test is significant, it then means that the fixed effect is better. Or if the p-value, if the t-statistics of the Hausman test is greater, it then means that the t-statistics is better. But if the t-statistics of the Hausman test is actually higher than 5%, it implies that the random effect is actually better than the fixed effect. So given the situation we find ourselves now, it is expected that we assert that the random effect estimation is better than the fixed effect estimation because the p-value of the Hausman test is insignificant, implying that the random effect is better than the fixed effect. So to have that done again, we'll go back to the estimation procedure. We select the random effect, we hit OK, and we get the result. This now becomes our random effect test, and this is how estimations are being done and decisions regarding what is expected are done. So in that note, a researcher will now copy this result and interpret according to the ceteris paribus interpretation. The random effect is actually better suited in this research than the fixed effect. Please, thank you for listening to this short video. Stay tuned to my other videos as I actually expose other biases in heterogeneous regression estimation using the panel data and other estimation procedure using this data. Thank you and God bless you. Please always visit my YouTube channel, Eviews Academy, Eviews Econometrics Knowledge Hub in YouTube, to actually patronize me, to actually expose this online academy. Thank you for being our fans. God bless and keep you.